Welcome to the Explainer. Today, we're going to decode the tiny, powerful brains that make all your favorite gadgets tick. So here's what we're diving into today. We're going to start with the basics, the brains in your devices. Then, we'll get into the anatomy of a processor. After that, it's the big CPU versus SoC showdown. We'll also ask, do more cores really mean more power? And finally, we'll wrap up by figuring out how to pick the right brain for the right job.
Okay, let's dive right in. And to really get a handle on this, we're going to start with the tech you and I use, well, every single day. I mean, think about it. We're just surrounded by these super smart devices, right? From the watch on your wrist to the laptop in your bag. And at the very core of every single one of them is this tiny, powerful brain making it all happen. But what is that brain exactly? Well, for a long, long time, the hero of our story has been the CPU, the central processing unit. And honestly, it totally earns the nickname the brain of the computer. It's the component that's crunching the numbers and executing all the instructions that make everything, from your mouse click to your video game, actually work. And this is where it gets really interesting with this fantastic analogy. Think about it. A CPU all by itself is a genius. It's like a brilliant chef who can come up with incredible recipes. But that chef can't actually cook anything without a kitchen, right? They need tools, ingredients, a stove, the whole setup. So with that in mind, let's peek inside that brilliant chef's brain and see just how it thinks. What really makes it tick. Okay, so when you break it down, a CPU is really made of two main parts that work together in perfect harmony. This diagram gives us a really simple but clear look at how they connect. So first up, you've got the control unit, or CU for short. The best way to think about this is like an orchestra conductor. It doesn't actually play an instrument, it's not doing the math, but it's the one directing the entire show. It fetches the instructions and tells all the other parts of the system what to do and when to do it. And that brings us to the second part, the ALU, which stands for arithmetic/logic unit. Now, if the CU is the conductor, the ALU is the entire orchestra. This is the real workhorse, the powerful calculator that's doing all the heavy lifting. All the addition, subtraction, and all those logical questions like, is this true or false? That's all the ALU. So these two parts, the CU and the ALU, work together in this constant fundamental loop. It's called the instruction cycle, and it has three simple steps. First, the CU fetches an instruction. Then it decodes it to figure out what needs to be done. And finally, it passes it off to the ALU to execute it. Fetch, decode, execute. Over and over again. That, in a nutshell, is how a computer thinks. But here's the thing, and this is the crucial point we keep coming back to. Our brilliant CPU chef, even with its amazing control unit conductor and its powerful ALU orchestra, is still just standing there. It's useless without a kitchen. It needs memory, ways to talk to the outside world, inputs and outputs, timers, all that stuff, to actually cook anything up. Okay, so that dilemma, the chef needing a kitchen, actually leads us to two very different solutions, two completely different kinds of kitchens, if you will. And that brings us to the challenger in this story, the system on a chip, or SoC. Now, instead of a standalone chef, imagine giving that chef a super compact, fully equipped, all-in-one kitchen that's built onto a single, tiny microchip. That is exactly what an SoC is. It's an entire computer system all bundled together, ready to go. So this really lays out the two different ways of thinking about it. The traditional approach with a CPU is modular. It's like you get your master chef and then you build a custom kitchen around them, right? You pick your own memory, your own graphics card, everything separately. But the SoC approach, that's all about integration. The chef comes with the kitchen. All the essential appliances are already built in and optimized to work together. Okay, so this difference in approach leads to some really important trade-offs. It's all about what you prioritize. With an SoC, because everything is so tightly packed together on one chip, it's way, way more power efficient. And it's cheaper to make. That's a huge win for battery-powered devices. On the other hand, a classic CPU-based system gives you incredible flexibility. You can swap out parts, you can upgrade things over time. And that's exactly why your phone almost certainly has an SoC, while a high-end gaming PC is built around a big, powerful, standalone CPU. But wait, there's more. Whether we're talking about a classic CPU or a modern SoC, there's another trick up their sleeve. See, just like you can have more than one chef in a busy kitchen, a processor can have more than one brain.
And that's where this word cores comes from. You've heard it a million times, dual core or quad core. Well, you can think of each single core as its own independent chef, its own complete processing unit. It's capable of working on its own set of tasks all by itself. So a dual core processor, that's 2 chefs. A quad core, 4 chefs, and so on.
And having multiple chefs, multiple cores, allows for true multitasking. It's a game changer. While one core is handling your operating system, another can be rendering a video, and maybe a third is running your web browser. This ability to work in parallel is exactly why multi-core processors are absolutely crucial for really demanding stuff like video editing or complex 3D rendering. But there is a catch, and it's a big one. It's described perfectly by something called Amdahl's law. Now, to put it simply, throwing more chefs in the kitchen only makes things faster if you have jobs that multiple chefs can actually work on at the same time. If you're just making one sandwich, 20 chefs aren't going to help. So you only get that big speed boost if the software itself is smart enough to split the work up and use all those cores. All right, so after all that, what's the takeaway? What does this all mean for the gadgets in our lives? Is there a clear winner? Is the CPU better, or is it the SoC? Well, the truth is, it's not really about one being better than the other. It's all about choosing the right brain for the job. CPU-based systems are the kings of flexibility and raw, upgradable power. That's why they're perfect for customizable desktop PCs. But SoCs? They are the absolute champions of power efficiency and compact size, which makes them the obvious perfect choice for anything that runs on a battery, like your smartphone or your smartwatch. And at the end of the day, a truly great device isn't just about cramming in the most powerful hardware you can find. The real magic happens when the hardware, the brain, and the software, the soul, blend together seamlessly. That's when you get a system that just works beautifully. So I'll leave you with this final thought to chew on. As our world gets more and more connected, and as smart devices get smaller and woven into literally everything we own, are we heading towards a future where the compact, super efficient, all-in-one SoC becomes the default brain for everything?